So before you watch this video, which will explain how to do multiplication, you should read the chapter on multiplying whole numbers because this is a supplement to that. So when you're asked to count a lot of things, if you can organize them into several different groups of the same value, then instead of counting and counting and counting, you can use what's called multiplication. So here we have all these pennies that we want to count. Instead of counting 1, 2, 3, what I'm going to do is I'm going to say, okay, in one row of pennies, there are 8 pennies. And there are 3 rows. So instead of sitting and counting 1, 2, 3, 4, 5, 6 all the way, what I'm going to do is I'm going to say, okay, 8 times 3. So I could do 8 plus 8 plus 8, but the shorthand for that is 8 times 3. And so we would say there are 24 pennies. Now let's try drawing out multiplication. So we want to do 7 times 4. So there will be 7 pennies or objects. I'll just represent them as dots by 4 rows. So we'll have 7 pennies. So 1, 2, 3, 4, 5, 6, 7. And I need to do that 4 times. So here's the second row. 1, 2, 3, 4, 5, 6, 7. And third row. 1, 2, 3, 4, 5, 6, 7. And the fourth row. 1, 2, 3, 4, 5, 6, 7. So now 7 times 4 will equal 28. So now you may be wondering, how do you know that 7 times 4 is 28? Well, there are some basic math facts that you should know. So let's fill in this multiplication chart, and I'll show you the patterns of how you're figuring what the multiplication is, and then eventually you'll use it so much that you'll then have it memorized. So in this first box here, I'm going to do 1 times 1. So 1 times 1. So that means I have one row with 1 penny. So there's 1 penny. In the next box to the right, 1 times 2, that's one row with 2 pennies. So there'll be 2 pennies. One row with 3 pennies would be 3 pennies. So then one row with 4 pennies would be 4 pennies. One row with 5 pennies would make 5 pennies. One row with 6 pennies would make 6 pennies. One row with 7 pennies would make 7 total pennies. One row with 8 pennies would make 8 total pennies. One row with 9 pennies would make 9 pennies. And one row with 10 pennies makes 10 pennies. What you should see here is that to get from one box to the next, you're just adding one more. Because we're multiplying by 1, we just keep adding 1. So now let's multiply by 2. So we'll have 2 times 1. That's 2 rows with 1 penny each. So there'll be 2 pennies. the next box over, 2 times 2, that would be 2 rows with 2 pennies each. That makes 4 total pennies. 2 rows with 3 pennies would make 6 pennies. 2 rows with 4 pennies would make 8 pennies. 2 rows with 5 pennies would make 10 pennies. 2 rows with 6 pennies would make 12 pennies. 2 rows with 7 pennies would make 14. 2 rows of 8 would make 16. 2 rows of 9 would make 18. And 2 rows of 10 would make 20. Now again, in this row, we're multiplying by 2. And if you look to get from one box to the next, you're just adding 2 each time. Okay, let's try the next row. So 3 times 1, so there's 3 rows with 1 each. So that would make 3. 3 rows with 2 each would make 6. 3 rows with 3 each would make 9. 3 rows with 4 each would make 12. 3 rows with 5 each would make 15. 3 rows with 6 each would make 18. 3 rows with 7 would make 21. 3 rows with 8 would make 24. 3 rows with 9 would make 27. And 3 rows with 10 would make 30. So now, what's the pattern in this row? Right? I'm multiplying by 3, and each time I'm adding 3 more. Let's try with 4s. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32. 4 times 9 is 36. And 4 times 10 is 40. Let's try by 5s. So 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. 5 times 7 is 35. 5 times 8 is 40. 5 times 9 is 45. And 5 times 10 is 50. So in that row, we're going up by 5s. In this next row, we're going up by 6. So 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 would be 30. 6 times 6, 36. 6 times 7 would be 42. 6 times 8, 48. 6 times 9, 54. And 6 times 10 is 60. Okay, row 7. So we're counting by 7s. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. And 7 times 10 is 70. So each time we're going up by 7. Let's count by 8s. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. 8 times 8 is 64. 8 times 9 is 72. and 8 times 8 is 80. Now let's count by nines. So 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 54, 9 times 7 is 63, 9 times 8 is 72, 9 times 9 is 81, and 9 times 10 is 90. And then lastly, let's count by tens. So 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40, 10 times 5 is 50, 10 times 6 is 60, 10 times 7 is 70, 10 times 8 is 80, 10 times 9 is 90, and 10 times 10 is 100. So these represent your multiplication up through 10. And you should know these numbers by heart. But if you forget them, then you have to go back to the basic, adding, the same number so many times. Now, there's some patterns that I'd like you to see. So pause the video and see if you can see any patterns, anything that stands out to you. The first thing that stands out to me is that when you're multiplying by 1, you always get the same number. So look at this top row. When you're multiplying by 1, you always get the number you're multiplying. So 1 times 6 will be 6. 1 times 9 will be 9. So anytime you multiply by 1, you just get that same number. Now, what's also kind of interesting is if you flip the order of multiplication, you get the same number. For example, in this box here, I did 1 times 9 versus in this box down here, down at the bottom of your screen, I did 9 times 1, and those both came out to 9. This is not a coincidence. Multiplication, you can flip the order and you will still get the same value. That's called the commutative property of multiplication. So now another pattern that stands out to me is the tens column or the tens row. When you're multiplying by 10, you just tack on a 0. For example, here is 4 times 10, and all we did was we took 4 and we tacked on the 0 to it to make 40. That's not a coincidence. That's a rule that anytime you're multiplying by 10, you just tack on a 0. So now there are two more basic properties of multiplication that I'd like to go over. So the first property is called multiplication by 0. Anytime you multiply by 0, the answer is 0. So 3 times 0 equals 0. And 0 times 394,723 will also be 0. Because what that represents is you have 0 rows with 394,723 pennies. You have no rows, so there's no pennies. The other rule, which I mentioned, is called the identity property. And that identity property says that when you're multiplying by 1, the answer is the same number. So if I take 96 and I multiply it by 1, I'll get 96. If I take 1 and I multiply it by 394,865, I'll get 394,865. So anytime you multiply by 0, the outcome is 0. And anytime you multiply by 1, the outcome is the number that you are multiplying. So now, let's multiply bigger numbers with a single digit. So the way we're going to do this is we're going to line up our numbers justified to the right, the larger number on top. And when I say larger, I mean more digits. So here we'll do 15 times 4. Now, when you're multiplying, you're going to multiply 1 by 1. So we're going to take 4 and we're going to times it by 5. So 4 times 5 makes 20. Now, underneath the ones digit, which in this case is 0, is going to come down, and the tens digit is going to go up as a carried number. Then we'll do the multiplication again. 4 times 1. So 4 times 1 equals 4. And then we have to carry this 2 down. So we're going to add the 2 to make 6. So the next digit is 6. What that means is 15 times 4 equals 60. Let's try it again. 64 times 8. So 64 times 8. So the first math that I'm going to do is 8 times 4. So you can look at your chart until you have it memorized. 8 times 4 is 32. The 2 is going to come downstairs. The 3 is going to go upstairs as a carry. Then we'll do 8 times 6. So looking at your chart, that makes 48. But now we've carried a 3. So when you carry something, you have to add it. So I get 51. So I'll write 51 downstairs. So what that means is 64 times 8 equals 512. Let's try another one. 57 times 6. 57 times 6. So we're going to multiply 6 times 7. That makes 42. So the 2 is going to come downstairs, and the 4 is going to get carried upstairs. Then we'll do 6 times 5. So 6 times 5 equals 30, but then we have to carry down 4, which makes 34. So I put my 34 there because there was not another digit to the left to carry. And what that means is 57 times 6 is 342. Let's try another one. 286 times 5. So 286 times 5. Here we're going to have to do 3 multiplies because there are 3 digits in that top number. So first we'll do 5 times 6. That makes 30. So 0 comes downstairs. 3 goes upstairs as a carry. Now we'll do 5 times 8. So 5 times 8 is 40. Then we have to also carry that 3, so plus 3 makes 43. So the 3 is going to go downstairs, and now this 4 gets carried upstairs. The reason it's getting carried is because there's another digit to do multiplication. So let's do one more multiplication. 5 times 2 makes 10, and then I have to add the 4 to make 14. So since there's no more digits to do multiplying, I just write 14 right out front. And so what that means is 286 times 5 makes 1,430. So this is the end of the basic math. We're going to have another video which shows you how to do bigger multiplication problems.